Understanding the Amazon Elastic Block Store. You'll have to forgive me. I'm having a technology moment right now. Between that last slide and this one, I thought about virtualization, and I just said, virtualization is so awesome. And it's just, I was overwhelmed with the coolness of this concept of taking a physical machine that is typically sitting there underutilized with a single operating system and breaking it into multiple, what Amazon would call instances, what a lot of other vendors would call virtual machines, that are all running and maximizing how much resource usage you're using on that one physical box, and totally blowing the doors off what you're able to do. But the topic here is actually the storage for those virtual servers. Where do they store their stuff? Before we talk about Elastic Block Store, come with me on a journey from where Amazon began in 2006 with only two kinds of storage available, S3 and ephemeral. So essentially, S3 is that super redundant storage dump bucket in the sky where you can put stuff, but it's not designed. It is not designed at all to run a machine from it. Meaning, as I power on, let's just say this Windows 2012 instance up here, it is not going to be able to run from S3 because that's not what it's designed to do. It would be terrible performance. Amazon doesn't even give you the option to do that. So what the Amazon of yesteryear would do is they would copy that AMI, that virtual hard drive, over to the ephemeral storage of the server that the instance was running on. Now, what's the ephemeral storage? Ephemeral storage is the local storage on that server. It's got its own hard drives inside of here, right? So it copies the AMI on there, you hit the play button, and bam, you're running Windows 2012 in the sky until you stop it. Until I turn that instance off, I hit the stop button, what happens to all the information that's on that ephemeral storage? Destroyed. It's erased. And you go back to the hard cold copy AMI of what it was. How's that for permanent storage, right? And that's really the mindset that Amazon started with is, you know what? Why do you want to permanently store things? Because you've got your systems designed so redundantly and with so many options of where you can store your data in a database or in S3 or all these different options. Why would you want to keep this around? Well, people, obviously that's a huge pill to swallow for people in 2006 coming into the I can't lose my server kind of feel. I mean, that's a radical concept for them back then. So what was developed was Elastic Block Store. Now, and I just got to finish my story. You can, after you're running in ephemeral storage, take a snapshot and actually update that AMI, but who wants to do that anytime you want to save your data that's inside of there? So Elastic Block Store was created as more of a permanent storage option. Now, if Amazon had their way, you would just say, oh, okay, got it. That's all there is to it. I'm not capable of just saying, and that's it, and that's how it works. Here's how it's really working behind the scenes. All these virtual, or I should say, all these physical machines, essentially the servers that are running the instances, right, the workhorses, are all connected to the network with mini network cards, right? That's what allows them to get the throughput that they need for the network. And also attached to that same network are storage servers. Now, this is where the mystery of Amazon comes in, for them to know and us to not care about, right? They will have servers, most likely servers, that are just packed full of hard drives, and mirrored together. That's how they get this annual failure rate of an EBS volume of 0.1 to 0.4%. Essentially, they're saying you may lose, the chances that you could lose in EBS volume, because the chance is there, is 0.1 to 0.4%. Compare that to S3, which has a 99.999% durability in there, and you go, wow, there's no comparison. But still, compared to running just a single hard drive, I mean, which you're in the 5–10% failure bracket every single year to have a single drive lost. Essentially, they're taking, most likely, and this is Jeremy filling in the gaps of what Amazon doesn't tell us, they're taking RAID 5 on both of these servers, which gives you redundancy of a single drive, and then mirroring it, which gives you redundancy between servers and additional redundancy of the drives to give you and deliver about this durability. That's probably about where that percentage would work out to, which makes you, it should make you feel really warm and fuzzy about these EBS volumes. So anyway, EBS, Elastic Block Store, is allowing the servers, instead of using their local storage, they'll actually run the Windows 2012 instance from there. Let's get into facts. EBS is just raw storage. That's all it's there for. They have a limit on EBS volumes from 1 gigabyte as a minimum size up to a terabyte or 1,000 gigabytes maximum size. Now, I know some people might be like, well, I want my servers to have more than a terabyte of space on them because of whatever the case is. Well, first off, I would say think that through. Think that through, because I'd question, are you using Amazon the right way? If you're storing massive amounts of information, typically somebody will rely on S3 to do something like that, right? But it's totally possible. So you go, okay, I want more than a terabyte of space. What do? You add multiple EBS volumes. You can attach. Think of these things, and this is where I'm like, I'm going to go back into my technology bliss again. It's amazing to where I can attach EBS Volume 1, EBS Volume 2, EBS Volume 3, as many EBS volumes to that server as I want to, I should say to that instance that's running. So this might show up as the D drive, this might show up as the E drive, the F drive, all that kind of stuff. If you're a Linux person, these will be different mount points on the Linux server. Or you can stripe those things together. Meaning I attach all 3 of those EBS volumes and I stripe them. It's called a stripe set. I'll actually talk about that as we get deeper into EBS later. Stripe them all together to where they act as a single drive, and believe it or not, you'll actually get even better performance from that, better input output operations and so on. So you can increase far beyond a single terabyte by doing that. You can attach, you can detach these things, you can snapshot them to back them up. Let me actually jump down here. Snapshotting converts these EBS volumes back into the cold turkey AMIs. I don't know why turkeys entered the picture, but you store them on S3. Again, we'll talk about snapshots later on in this series as we expand on EBS, but this allows you to either A, store it as just a backup. So if something goes wrong, if you happen to fall into one of these 0.1% brackets, you still have all of your data stored in a backup state, or you can use it to generate new machines. You create your perfect Windows 2012 instance, and you say, okay, now I want 50 of those things. Bam, 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 bam. And it starts generating those, bootstrapping those things so they boot up uniquely, and then you've got a whole fleet of those machines on the fly. Right? These are, and I've mentioned this already, EBS is replicated to additional devices, like I was showing you right here. It's not just a single storage device, it's multiple. How many? Again, that's behind the shroud of Amazon silence. As we wrap up this nugget, I just want to navigate over to show you where EBS lives. I'm heading to the land of EC2, virtual servers in the cloud, and I see that I have one instance right now. It's turned off, it's stopped, called Ubuntu Test, right? Drop down over here on the left-hand side, I've got the elastic block store. There's my volumes. This is my one volume I have attached to my Ubuntu test server. Now, notice that, first off, it's 8 gigabytes, and I'm paying for every one of those gigabytes on a monthly basis. The amount I pay, it depends on what kind of server storage I choose. Nowadays, a lot of people are choosing solid-state disks, which give you faster speed, more IOPS, those kind of things. It's just faster performance, rather than the old magnetic storage of yesteryear, the typical platter-based hard drives clicking away, doing their thing. Now, you can get magnetic storage, and it's typically, I've seen, half the price of the solid-state disk. So if you just need a bunch of file storage cheap, go magnetic. If you don't really care about the performance. Operating system, stuff like, I'm getting ahead of myself. I'm going to talk all about performance on EBS later on. So notice that even though it's on the server that is powered down, if I look right here, that's my Ubuntu test server, it still shows green in use. And that's just because it's attached to the storage. From here, if I want to back it up, I can just right-click on it, create a snapshot, and I'll just say, this is my backup, name it, give it a description of, the date, the time, whatever you want to put in there. Hit create, and it actually is now backing that up into S3. It doesn't show S3 right here, but right now you can see it's pending backup. It's copying a copy of that from the volume side into that. Again, more on backups in a little while. If I want, I can create my volumes from here. What kind of volume is what it's asking. Do you want just solid-state disks? And they're saying, you know what, IOPS can be anywhere from 300 IOPS. By the way, IOPS, input-output operations per second, is essentially how fast your hard drive is working, right? So it can be from 300 to 3,000 based on, notice they're using the formula, based on you get 3 IOPS per gigabyte of storage that you're creating. So when I'm creating a 100 gigabyte volume, I'm guaranteed, in a nutshell, 100 or 300 IOPS for that storage. If I drop down, notice right here to magnetic, IOPS just go away. They're like, yeah, magnetic. It's kind of whatever you get is what you get. There's no guarantee on anything, but again, you're going to get something, which is why this is good for typical file storage. So choose your storage type, choose where you want to put it. So I might say, you know, I want a 100 gigabyte, let's just go with 50, right? A 50 gigabyte magnetic store sitting in, and this is what data center in Virginia, the east region of Amazon. Which data center do you want to put this in? And you typically want to put this wherever you plan to run your EC2 instances from, right? If you want, you can actually generate this from an existing snapshot. And notice right here, I can say I want to build a, and this is a good point. I want to build a EBS volume from a snapshot that I've already created. Now, the cool thing is this. When you do this, it allows you to increase the size, right? Previously, my volume store was 8 gigabytes, but I can say, you know what? I want to expand it. Man, that's so awesome. I want to expand that to 50 gigabytes. I mean, typically, you have to get all these, you know, partitioning, read tools, things, right, to make that happen. Just a built-in feature of Amazon. So you can generate this from an existing snapshot that you've got or someone else has that they've shared out. Or you can just say, you know what, it is a blank volume. If you want to encrypt it, you can, and that's it. Right? Now all you have to do is let that thing create itself and then attach that volume. I know it's grayed out because it's still creating right now. Attach it to whatever instance you want to. You now understand the core of the Elastic Block Store, what it is and how to use it. I hope this has been informative for you, and I'd like to thank you for viewing.